Hello and welcome. So today I will be explaining what the REST Notify API is, and this is just a brief overview of what it looks like, or just the idea of it, just a brainstorming map, right? Before I jump into explaining the structure of this API, I want to brush over. In order to issue a notification on my system, I'm using Dunst, which is for Linux, and it is a notification daemon. The command that you would issue is basically you can issue a command called notify send, which will be referenced a lot as a naming convention for my API, and basically you could do this and it would issue a notification. So that said, for the REST Notify API, there's going to be an Express server in the middle, listening for incoming messages with this type of body. There's going to be a title, a summary, a body, and an urgency and an icon. So the urgency basically is going to be an enum, which has low, normal, or critical. The reason for this is with Dunst, you could actually you can specify different urgencies. So different urgencies have different colors depending on how you configure it, and different durations. And the icon is going to be raw bytes, so we're going to have to take the image and convert it into just a raw byte array and send it. And onto the security side. For the security side, in order to not have anyone just bombard this API, there's going to be an RSA. It's going to use RSA in order to verify the user or who sent it. The other device is going to sign the encrypted message. It's going to sign a message and send it to the API, and then the API is going to verify that signature and look at its whitelisted devices that can issue notifications, and if so, it will issue a notification. Now, aside from that, there's going to be a packet size limit, just in case, you're not going to be sending, like a couple megabytes of you're not going to be sending a huge packet just to issue a simple notification. And for extra security, I'm going to use the helmet package from npm. This is basically just what this says right here. It helps secure your Express app by setting various HTTP headers. Alright, so now that we have planned out what this project is going to be, let's get started by initializing the project. Simple initialization, just as simple as that. Just initialize the package information. Alright, let's install the essentials. Let's install their types because we're going to be using TypeScript. Alright, let's install TypeScript, ESLint, and prettier ESLint to make everything look very nice and follow a structured convention. Alright, now that that's done, let's install its types. Alright, one final stage, we're going to install temp, which I'll explain in a second. And we're going to install NoDaemon to help develop this project and just easy reloading of the project when we build. Alright, let me explain what the packages that I just installed are. So temp is just a simple package that I found to handle temporary file creation and deletion. Joy is just what it says over here. It's a schema description language and data validator. I will be using it as a data validator. I will have the as I showed before, the structure of the message is going to help validate that message structure for us, and then all we need to do is just have some restrictions on it, what type it is, the length, stuff like that. And Morgan is one of the most essential tools and packages that anyone could ever have. It's a middleware. Basically, it is for logging. It helps log all the requests that go to the Express app, and there are multiple options for it. There's Tiny, there are multiple ones. I'm not sure if it says it over here. However, with TypeScript, it will show all the different options. So, yeah. Alright, before we start, I'll explain these scripts real quick. So build, all it does is just runs TypeScript, which just runs the TypeScript config and builds the files according to the config. with watch, it will watch for changes in the file in the source directory, and then it will only output the changed file, or the file that was changed compiled to the transpiled file that was changed. Geez, that was hard to say. So in start, all it does is just compiles and starts the program, and no daemon just watches for the output. So all right, we're almost there. Now I will be configuring TypeScript and ESLint. Now for these two, I will show you how to generate one yourself, but I'm going to be using a predetermined one, pre-configured one. So you could run npx. Npx basically just runs a command from, well, it runs a package that is installed either in the current directory or globally, or it will download it and place it globally if not. Either way, you could put TypeScript, so TypeScript, I believe it's init, like so. Nope, it's init. It's not TypeScript, it's CSC. Oh my god, I suck at this. It's init, there you go. So this will generate a default config for it, and then you could just go through the explanations for each one, change them. With VS Code, it will show you the different options, which is very, very nice. Now let's do the same thing with ESLint. I believe it's like this. There you go. And now we'll ask a couple questions, which is very, very nice. We're just going to check for syntax and find problems. It is going to be a JavaScript module. Technically, it's not JavaScript. It's going to be TypeScript, but we'll put that. We're not going to be using a framework, front-end framework. And there we go, TypeScript. Yes. This will be a Node project. And which format? JSON, always. I've never tried YAML. YAML probably would look good. Would you like to install them now with npm? No, because I already installed it. So you would put yes for that, but I've already installed those right here. So that will generate an ESLint config, and we have a TS config, so we're ready to go. I will be pasting the my pre-configured ones. All right, now that I have my configurations, I won't go too detailed into what these are. If you want, you could learn more on the respected documentation pages, which are over here. So this is the TypeScript configurations. You could go through and just figure out what each of them is. Similarly with the ESLint, I will remember to put links in the description, so if you really want to look into this. All right, let's finally get coding. Let me clear this. So in the source, the root file is going to be index.tsc for TypeScript. So we're going to start by importing all of the libraries that we're going to be using. So if you see this issue right here, which, I mean, if you read it, it says it does not have a declaration, and it tells you what to do. Basically just run this. I forgot the end, I know. Both ends. And yeah, that's it. There you go. And now we're going to set up the app. We are then going to initialize the middlewares. So real quick, let me explain this. Like I mentioned earlier, I wanted to limit the packet size, so I limited it to 200 kilobytes. As for the middlewares, for Morgan, I wanted a short description of the logs. And we're going to start the app right here. The Express app is going to listen to port 3000 on the local host. All right, so let's configure the Express app routes. There you go. That's pretty much it for the notify route. Now we're going to set up the router, and then we're just going to have a post request on the root, which I'll explain why the root in just a second. Now to clean things up, I like to have an index under routes. That way you could just import routes, and then from the routes you could decompose the different routes that you could take. By that I mean like so. Since we've exported the app from here, we exported the router. We could rename the router, right? We could just have an alias called notify, and we could export this route like so. So you could imagine we have multiple of these, and then you could just have multiple exports of that. And then you could have a route imports right there. So just like I explained before, if you have multiple exports, you could just have, so notify the notify route, you could have whatever else right here. You could just keep going and going. And let's register this route under this path. So this is the naming convention that I've picked up. So it is an API, it's the first version, and then it's under notify, which is why it was the root. All right, so now let's configure the schema that we're expecting from the message. So under this, so notify message schema, we're going to use Joy to help us validate the schema, the data validator. So this is the expected message. It's going to have a title of type string, summary of type string, body of type string, and then there's going to be an urgency, which is going to have three different types of, it's an enum, so three different urgency types. And the icon is a buffer. Now this is constructing the notify schema. So the title is going to be a string, like I said before. This is just to help with organizing TypeScript. So it's going to have a max of 80 characters. It's going to be lowercase, and and the title is required. The summary, same thing. It's going to have max of 128 characters. Body is 256. These are just random numbers I picked. Well, not random, but just numbers that I thought would be pretty decent limitations, right? As for the urgency, you could specify validity, what types you could have. So I restricted it to low, normal, and critical, like we've discussed with the enum. And then the default is low. So with the icon, like I said before, it's a binary, it's a buffer array, and it is optional. All right, so let's set up the config. So with the config, it's going to have a configuration of what is expected, who is the one sending the request, and its associated key. So this is basically it. It is a configuration with a key value pair. The key is going to be the IP, right? The IP of that device, and then the string is going to be the name of the public key, the RSA public key of that device. And then that's what we're going to use to validate the signature. All right, so let's start building the notify route by first creating the interface that we're expecting. So for the request, when that device sends a request, this is the expected body of the request. It's going to have a data, and the data is the notification message that we've created before. You can import it like so with Visual Studio Code. Let's tidy things up by having a libraries section. So like I mentioned before, the data we're expecting is a notification message, which we've defined over here, and we use the notify schema using Joy to help validate the data. And then we also expect headers, and within the header there's going to be the signature that we're expecting, that we've discussed before about the RSA signature. For the authorization header, we're expecting a buffer. So a buffer object, and the buffer object basically holds this when you serialize it. All right, now that that's done, let's configure the temp package that we downloaded before. So in order to do so, we need to import it and then set it up like so. This just helps track the temporary files that are not in use anymore and then helps delete them. And like I said before, if it doesn't have the type declaration, you could just install it. All right, let's get started. So first things first, we need to obtain the IP of the requester, and we do so like this. We need the join function from node, which is included by node, and it is under the path. So it's just join, and we're going to use the config that we created earlier, this config right here, which holds the configurations that we're expecting, the IP that we're expecting. So the way this works is within the request, there's an IP object that holds the IP, the entire length of the IP, and then you split it on, and then we're going to split it on colon, and then once we split it on colon, we need to get the end of that IP, which holds the IPv4 of that requester, and then we're going to get the key name, the public key name of that requester that we've stored in the config. We're then going to create a key path to where we're going to store that key on the server. So then the server can get that public key to verify the signature. Those public keys will be stored under keys, the keys directory right here, as of what this is for. So with a directory name, since it's going to be compiled to out and it's going to be under notify, it's going to go back one to out and then back another one to the root directory and then into keys. Hence these two and then keys. And join helps join it depending on the platform that you're using. And then it helps just create a relative link, relative URL to that file. And before we continue, we need to verify that this public key exists, like so. If not, we stop right here and we send back a message to the user to notify them that, hey, there's no IP here. So if the public key exists, we're going to be reading that file synchronously. Since this is an async function, we're going to be reading that file where the key path is. So this path, the path to the keys, we're restoring the public keys, and then the name of that key. In order to do so, we need the write and read methods from Node under the FS library. So we're going to use a write file sync later on. So now we're going to verify the packet. We're going to wrap it around a try catch statement, because if you try to verify the signature and it fails, it will throw an exception, which is what this will catch. And if there's an exception, we want to stop right there and then notify the user that you are unauthorized and just to stop. So we need the crypto library in order to verify this packet. All right, now we're going to get the body and headers. Then we're going to get the signature from there, just like I explained before. If there's an authorization, you create a buffer from it. And then this serialized buffer, which has a type and a buffer or a string, will help JavaScript know how to create the buffer from it. So that's exactly what we're going to do here. Buffer from, you send in the data, and that's it. Now, in order to verify the signature, you create a verify object. This is the encryption algorithm that we're going to use. And then you simply issue this, which basically takes this data and pushes it into this object, and then that's it. So what we did right here, what this did right here, is it took that object, that data packet, and then embedded it into it set the data into the verify object. It has not verified anything yet. It has just wrote this data into it. This is where the signature will get verified. So if the signature is null from this, we simply just throw an error, stop right there, and then just say invalid signature. If not, then we try to verify. This is where it's verifying the signature. It takes in the public key that we've read from the file previously, and then it takes this signature that we've read from the header. And if this fails, then of course it's an invalid signature. So now that the signature is valid and the data is authenticated, we need to verify that the data being sent is authentic, is what we expected. So first things first, we need to verify that the icon is valid. So if there is an icon and there's an icon type and the type is a buffer, because we expect a buffer, right, for the icon, then convert this icon into an actual buffer type, into an actual buffer object. Once we've handled the icon, we need to verify the rest of the body. In order to do so, we're going to use the notify schema, which we're going to import. This is how you validate. You just call the validate method. It returns this is just destructuring. It returns an object, and within that object, there's a key called error. And if there is an error, then just stop right there. There's no data that is expected, and then just return to the client. Now, if all the data is valid, we need to temporarily create the icon so that notify send can actually take that icon and display it. So in order for notify send to actually take an icon, it needs to be a file. It needs to have a path to that file, which is exactly what we're doing here. We're creating a temporary file with that path that this file created. So this the temp package will handle creating the file and everything. So this will give us a path. We'll then take the icon and convert it to a string with the binary encoding, and then that will write it to the temporary file. Once that is all good, we need to construct the command that we're going to execute for notify send, like so. So we're going to have the script path where the script is going to be called. Now, you cannot call You cannot call notify send right away, like directly, like so. So just bin notify send. You cannot do that because it requires, depending on how you launch this application, will require that the environment variables for just the environment is exported to the dbus. It's very complex. I don't understand it fully, but I do have a script for it, which I will explain in a second. But this is where the path to that script is going to be. We're going to have a script in the root directory that will hold this script, and then we're going to construct these arguments. We're going to have the title, the summary, and the body. As for the script, it is this behemoth right here. Basically gets the session ID of the user, right? Just gets the user, tells some data, gets the session ID for that user. I'm not going to go into too much detail into this, but basically gets the session ID, then goes in and finds the environments for that session ID and exports it to the dbus, and then just forwards the parameters that were sent, which were these, into notify.send. Now constructing the icon arguments. If there is an icon, then append this. Now to handle the icon arguments, if there is an icon, then this is the argument that we're going to have into, so basically sending I and then the path to that icon. If not, then there's just nothing. I will explain why I did it like so in a second. It will make a lot more sense in just a second. And then this is where we issue the command. So this is how you spawn the command. You call a spawn, which we're going to include in just a second. It's a library for spawning child processes. We pass in the script path and then its arguments. And then this is where this comes in. We're going to use the spread operator for the icon arguments and the command arguments afterwards. And then let's import the spawn method from the child processes from node. Once that is done, in order to listen for this child process, I created this promise, which will help clean things up instead of because we have to listen to an event that happens from the child process. So I created this promise and just awaited on it to finish up. This promise basically resolves when it closes and then rejects when some error happens. If this resolves, then we issue a status 200, so it's a successful execution. It's a successful request, and then we notify the user that it was notified with a very important rocket. If not, then something bad happened and I have no idea what it is, which is why it's a 500 status code with the error passed back to the client, because the client very well needs to know the internal error. Do they? Sometimes they do. And then once all of that is done, we of course need to clean things up like so. So there's a finally method or callback for this promise, and I absolutely love promises. So once this is done, you tell this temp stream that we created, the temporary file, that it ended, and then we explicitly tell temp to clean up synchronously, because it's very important. You could do it async. There was a lot of play with this, but I found that this was the best approach to take, and this just waits until clean happens. So within this request, it will wait. Within this request, it will notify the user that the submission was good, the request was successful, and then afterward, in the background, it will clean things up and wait for this to be done. So there's no halting on the client side. There's no anything. Everything is just clean and it works. All right, we're all done with the notify route. One really cool and easy script that I created to generate keys is this: generate SSH keys. Basically, it just uses OpenSSL to generate an RSA encryption key, a private key, 4096-bit, and then once that is done, then I take the private key and create a PEM key out of it. So and then that PEM file we're going to use to verify the signature. So let's do just that. Let's actually test this out. So I will be SSHing into a device I have on the local network. There we go. All right, let's go into a very secure environment. I'm joking, by the way. Let's create some keys. Now with the keys, you could run this script, or you could just run each one by itself. So like I said, we're going to create the private key. That's taking a while. There we go. We have the private key right there. I can actually show you it. There you go. It's huge. Doesn't matter. I'm going to delete it right after. So don't you dare copy this. I'm joking. And then we're going to generate the public key out of that private key. Just like that. And then this is the public key. Very easy, very simple. So you can actually copy it or you can SCP it. All right, so now let's create a simple notification or simple notify request from the client side. In order to do so, we need these libraries. We need Axios to help us initialize this post request. We're going to use crypto to help, well, sign the packet, read file to help read in this the private key, and exit to exit. Yes, we're going to exit this process. Easy. Now we're going to sign some data. In order to do so, we can actually include just some icon, which I will show you in just a second. So don't worry about this error right here. This is going to be running on the client side, so this is just an example. Then we're going to construct the data packet. So it has a title, summary, and a body. It's a very cool body. And the urgency is just low. I will show you different urgencies. And then you could have an icon. I commented these two icons to show you that you don't have to send in an icon. And then this is where the signing process happens. So similarly with the server side, on the Express app, we create a signature, which is SHA-256. We load in the data, we end the stream for loading the data, and then we sign it using the private key that we've read before. And now we have a signature that we're going to send into the authorized headers. Once that is complete, now we're going to execute. Now we're going to issue the post. So depending on where your server is running on, depends on what this IP is going to be, hence this note right here. So we're going to send in the data. This is just an ES6, I believe, syntax. Is it ES6 or ES5? I think it's ES5. I don't recall, but you can. This is basically it's doing this. So we're sending in the data and the headers with the authorization, and within the authorization, we're sending in the signature. And like I explained before, the signature is actually a buffer, just like so, which is why we're doing the type and data on the server side. And then once this post request is successful and you get a response, then we handle that response. All right, let us start transferring some data. So let's just move over this client code over to here. So paste it, make sure to give the file a name, and then save it. Even better, because we need to make it a module. I forgot about that. Now we need to copy over the public key. Let's call it something cool. So this is the PEM file, which is the public key. Now we have the public key in here. Now let's go back to the config that we had before. So right here, now we're going to add a configuration. So we're expecting this to be from some IP, and we copy the file name like so. And then now we need the IP address of that device that we're expecting data from. There we go. Now we have, now we configure the IP address for that. All right, now it's moment of truth. We could run no daemon, which will just, like I explained before, for development purposes. I'm just going to start it because I believe in the heart of the cards. There you go, it's running. All right, now this is all good and dandy. Before I run anything on the client side, I need to have the packages that are located right here. So we'll install Axios. And actually, let's just try and run it. And moment of truth. Signature failed. Excuse me. I'm actually not sure as to why the signature verification is invalid right here. So I'll tell you what happens. So if you have an image, well, if you don't have an image, then the signature fails. Yet if you have an image, so I have an image file that I imported from here, and then once you execute it, you get an image and the notification and a really cool puppy. But for some reason, the data is never manipulated. So here's a really cool / not cool weird thing, right? The data is not manipulated. I console logged before right here and afterwards, and the data is still the same. So it was not some weird like data manipulation kind of thing, even though it's const. Either way, there's no data change. So what I'm suspecting is the encryption is too large to where the data being sent is so small that it can't sign it. Either way, it works. So with an image, so that tells you have to have an image of a cool puppy for it to work. Yeah, so this is pretty much it for this project. I will have links in the description for the repository. that you could go and check out. I also have links to the libraries that I've used. And yeah, hope you enjoyed, and yeah, see you.